Lesson 88, we're going to look at solving and graphing linear inequalities. In the past, we've done graphing and solving linear equalities. Now we're simply going to do inequalities. That just means we're changing our sign here. Previously, this has been an equal sign. Now it's going to be a greater than, less than, or a greater than or equal to, or less than or equal to. So first, let's understand the solving part. Trying to make sure it's not getting blurry here. Okay, it says solve for 3x plus 2y is greater than 1. And I'm actually going to solve and graph it. So we got to get in form of y equals mx plus b. The only thing is our sign may be subject to change because it's an inequality. So I'm going to subtract 3x and have 2y is greater than negative 3x plus 1. Then from there I need to divide by 2y, or sorry, divide by 2. So I get y is greater than negative 3 halves x plus 1 half. And that would be how I solve for my solution. I just get y by itself. Now let's say I was graphing this. I'm going to go ahead and erase this portion. Okay. Let's say I was now needing to graph y is greater than negative 3 halves x plus 1 half. Well, I'm going to draw my coordinate grid. I'm going to locate my y-intercept just like I normally would, 1 half. And then I'm going to go in my slope. It's a negative 3 halves. So I'm going to go down 3, 1, 2, 3, and go to the right twice, up 3, to the left twice. Now here, generally in the past, we just drew a straight line. And now what you got to know is if you have a greater than or a less than sign, and it's on its own, you are actually going to draw a dotted line. A dotted line. And then from there, well, my answers are for y and x are not on this line. It's actually, since y is greater than, it's actually above. So I'm actually going to shade above, showing this is where all the solutions for y and x would be. So for example, all right, let's look at the coordinate 3, 0. 3, 0. I can always check it by plugging it in for x and y and seeing if it would work. So in the coordinate 3, 0, 3 is my x. Well, I'm going to plug in 3 for, I'll tell you what, we'll do 2, 0 instead, just because it'll be a little easier. 2, 0. Okay, well, I'm going to plug in 0 is greater than negative 3 over 2 times 2 plus 1 half. And if this works out, if 0 is greater than this number, then I shade it in the right direction. So, negative 3 halves times 2 would be negative 3. Negative 3 plus 1 half would be negative 2 and 1 half. 0 is greater than negative 2 and 1 half, so therefore, boom, we graphed it correctly. And that's how you graph linear inequalities. I just want to look at one more. So those were greater than or less than signs. Now in example 2, example 2b, it says graph y is greater than or equal to 2x minus 1. So we do the same thing. It's already got it in y by itself for us. So I go to my y-intercept b, or negative 1. I use my slope up 2 over 1 down to the left one. Now the difference here is if I have a less than or equal to sign or a greater than or equal to sign, this changes it because I can draw a solid line. Reason being, if I have an x or y coordinate that's on this line, that would be greater than or equal to. And now I shade. Okay, since y is greater than, I need to shade in that area. And if I wanted to check it, well, 0, 0 looks like it's in the shaded side, so if I plugged in 0, that was kind of scrabbled, but if I plug this in, 0 is greater than or equal to 0 minus 1, well, that's correct. So that shows me that I shaded in the proper area. All these coordinates where I shaded, the inequality would be able to work. So that is how you graph and solve linear inequalities.